Hello guys, today we are going to discuss Leetcode number 445, that is add two numbers to problem. Let's see the problem and understand the problem very clearly. That is, let's see in study once. You are given two non-empty linked lists representing two non-negative integers. The most significant bit comes first and each of their node contains a single digit. Add the two numbers and return the sum as linked list. That means we have to keep in mind that they have given here two key points. The most significant bit digit comes first and each of their node contains a single digit. That means they have given a number in most significant bit order. That means this is least significant bit that they mean. This is ones place, this is hundreds, this is thousands, and this is 10,000s. Is it? Ones, tens, hundreds, and thousands. This is a high significant bit. That is, this is thousands place. That is their point. Okay, and they said that each node contains single digit. That means each node contains a single digit only. That doesn't have numbers like greater than 10 or equal to 10. And what they need, add the two numbers and return the sum as a linked list. We have to simply add this, and we return their answer, their sum as linked list. That's it. That's our question. Let's come, guys. If you have watched already my previous video, that is add two numbers one series. In that problem, they have they given numbers linked list as least significant order. Least significant order means we had done that problem. If you already have done that problem, just see the approach and try to do on its own. Okay, our approach is here. Okay, they get given list 1 like this and the given list 2 like this. That means they mean our number is 7243 and they mean the other number is 564, and we have to return this, the sum of them, in the linked list order. Okay, we they asked what operation. They asked about addition operation, like addition or subtraction operations we do from least significant bit only, right? That means we do from in the opposite order. We add 3 plus 4, and then we add 6 plus 4, and then we add. This is how the process continues, right? That means we are doing our operation from the end. In linked list, we cannot keep track of this when you are in this place. We cannot keep track of previous node. So we simply reverse our list. Both the lists are going to be reversed. We are making them as reverse. That is, there's going to be 7 2 4 3 is going to become 3 4 2 7. Okay, and similarly, this is also going to become 4 6 5. That's happening here. See, check once, 3 4 2 7, and here check once, there's going to be, okay, 4 6 5, right? And then from this here the head is present, and here this head is present of two nodes, two linked lists, sorry. And now we have to do our operation, that is addition operation. We will do it, and the answer we get will be also in the least significant bit order only, right? So that in the last step, we simply reverse our solution and make that as answer. That's it. While you're adding, this will become, our head is pointing to this, no, this 7, and then this is how the our answer from second node will get. So our answer should be in more significant bit order only. So we don't want, we just simply reverse this, what we have got from the second step. Okay, hope you guys understood my approach very clearly. That here here they are asking simple addition operation. They have given in the order of most significant best bit is stayed first, And as addition or subtraction, this type of operations are going to be start from the least significant bit. In linked list, we cannot track the previous node, so we simply reverse the list and apply add to numbers logic. That's it. And we simply reverse the solution we have got from the second step and simply reverse it and make it as answer. That's it. Hope you guys know a reversing of linked list. If you guys don't know, please watch this. Otherwise, you can skip this part and move to the next part. Reversing is nothing but uh, the any node just breaking bond with the next node and just making bond with the previous node. That's it. That's the reversing of linked list. Each node is going to break bond with the next node and just make bond with the previous node. Okay, that's the then the order now it's like one, two, three, and four, right? Then the order is going to become like four, three, two, one. Okay, let's see this approach. I have written only one iteration here. This is how it continues till current is not equal to null. Is how many iterations depends on the size of the list, linked list. Okay, let's try run this simple code. We have taken three pointers, right? That is previous, current, and next. Previous is pointing to null, that is here, and current is pointing to head, that is head. Okay, and when it come enters into the loop, when we declares a next node, and next is going to be current next. This is how the current next is to, right? So next is pointing to this, and then current or next is got a previous. See, this is current node next is going to become this, that is making bond with the previous one. Automatically it's breaking bond with the next one. Okay, that's it. And when it come to current equal to next, its work has completed, so current is simply moving here, and previous is going to become the current. Okay, and then if you see here, previous is going to break down that link here, and it's going to become current. Current is going to break down its bond here, and it's going to become the next. Now, finally, after completion running of these four steps, they are here. Previous is pointing to 1, current is pointing to 2, and next is declared. And when it runs like this, it's going to pointing to 3, and again this type of loop is going to be run. And when it comes to null, current is going to comes to null, then current previous is going to point to here, right? So we return previous. We return the head part of node only in linked list. This is the link reversing the linked list. We just want to keep in mind is nothing but just break the bond with the next one and make the bond with the previous one. That's it. Okay, let's move on. This is our addition approach. Okay, we have discussed that we have reversed our list, right? Now it became like this and this. So this 3 and 4 are here. Okay, we do operation from least significant bit side. Now this is the least significant bit side. Okay, hopefully I think you had understood it. Okay, now these are the least bit orders. uh, this L1 is the list 1, and this L2 is the list 2. These are the pointers. These are pointing to the heads of the L1 list and L2 list. Okay, and now we know simple addition operations, right? We simply add list 1 node value and list 2 node value. That will become 7. And we are not going to take another linked list here and keep adding our result. We simply updating any one of this. you wish, it's up to you. L1 you can take or L2 you can take. I taken here L1 and updated L1 list with our answer. So your wish, it's up to you. You may take L1 or L2. We don't want to take another extra space for it by creating another result or any sum linked list like that. Simply updating here L1 plus L2 equal to 7. Simply update here in L1 3 place, we get 7, and we just simply move. We completed our operation in this node, right? In both the list, we completed operation in this node. We simply move our pointers to next. So they are here right now. And now we apply our operation addition, that is 10. But if you have to keep in mind that we got here two digits. This is other than single digit. So we just only keep the units place in our list. In place of 4, we are going to update it as 0. And carry is going to become other than units place, that is 1 here. So carry became 1, and the pointers here, our operation is completed. So the pointer is going to move to the next node. That is L1 is going to become point here, and L2 is going to point here. And carry is now 1. Okay, now they are here, and carry is 1 here. And now simple addition operation, 2 plus 5, and carry is 1. So it become 8. Simply update in this 2 place as 8. See, in that 2 position, it became 8. Okay. If you observe here, there is nothing node other than next to L2. So it points to null. And if you observe here, L1 still has node. That means it is we assume that we are updating that our result in L1 only, no. So we don't want to create any other new node or nothing. We simply update our answer in that node only. So here, as there is no carry, nothing at all, there is no L2 dot value. So simply again traverse. That's how it happens. It moves till L1 dot next till there is no other node next to it. Till that it moves and returns that list. That means it moves to 7. Other than next to 7, there is nothing. So it stops here and returns 7. That means return L1. That means now the answer from the second step is 7, 0, 8, 7. See, this is 7. Okay, this is how it is. And this is going to be 8 carry, and this is all we discussed, 8. And here it's going to be units place, 6 plus 4 units place is 0, and previous this is summation is 7. This is how our answer from the second step. Okay, this is the least significant bit order of our solution, so we want to make it as more significant bit order. So we simply just do reversing of it is our final answer. Okay, what we have discussed, just once we simply recap it, that is, we are simply reversing both. As our operation is addition, this is going to be done from the least significant bit only. Simply doing our operation, making handling our carry, moving forward, handling our list sizes, and moving forward and updating our node values, and simply lastly reversing our result from the second node. That's our final answer. Okay, now let's see our code in Java. I wanted to do, it's up to you. So that only I have made very clear of what these are the steps. Simply want to write in your own language. That might be JavaScript, that might be Python, that might be anything else, C star, something like that. I have here given in Java. Okay, simply we are reversing, we are traversing. See, if one L2 or any L1 or L2 completes its traversal, even though there is other one exists, still we have to continue our traversal. Okay, we are tracking their values. If L1 is not null, that might have value, then taking that value. If it's null, then we are taking 0. That's all happening here, and we are adding it into adding all and keeping it into n. Okay, then updating node value and carry. Node value, how can you update if the n value is greater than 10 or equal to 10? You keep node value as last digit and keep the carry as a remaining part other than last digit, right? That's how you are managing here. Otherwise, if there is a single digit, simply you update the node value and make the carry as 0. That's it, right? Okay, I want to discuss one case for you. That is, if L1 dot size, this size is lesser and this size is bigger. Let's consider that. In L1, there is only 3, 4 nodes on preset. There is no 2 and 7. And in L2, there is a 4, 6, 5. Okay, we are updating our result in L1, right? So, what we want to do is, we just want to create another node and point L1 dot next to that node. Let's assume that here we have created this node. If this node we have created and we updated our result in this node, and we have to point this L1 dot next. That means this node to this node. So that our answer is going to be updated in our result list. Okay, that's what happening. See, L1 became null, but L2 still has values. So you're creating a list and pointing it to L1 dot next. Okay, after completion of a node updation, after completion of here both node updation, you're simply moving, right? See, you have completed this too, simply moving to next. That's what happening. That's what here we are coding. L1 complete, after this complete is happened, operation happened, and now we are moving to the next. Okay, in case of 6 plus 4, there is only one node. So 6 plus 4 equal to 10. Seriously listen this. That is least significant bit means here 0. 0 is going to be updated in the node and here carry is going to become 1. That means carry is containing something value. That means in answer also carry is also part of it, right? 6 plus 4 is 10. Here 1 is also part of our answer, right? 1. So, if carry is greater than 0, after complete addition of L1 and L2, if still there is extra digit we got it, then we create node and point our last node next to the node. That's what happening here. And we get
Thanks for watching. Don't
under
forget to
here,
like the
we
video,
get
share
a
this to your
least
friends.
significant order. So simply we reverse it and result the return the result. That's it. Thank you guys.
Thanks for watching. Don't forget to like the video, share this to your friends.